Hello, today we're going to do a bit of revision of our trigonometric ratios, which is the formal name for sine, cos and tan, and we're going to look a little bit at degrees and minutes, which is just another way of measuring angles, and at some special angles, 30, 60 and 45, that are important for lots of our work, or some of our work in trigonometry. Now, as a quick recap of sine, cos and tan, we have right angle triangles, so sine, cos and tan are only defined for right angle triangles. We're going to deal with non-right angle triangles in trigonometry, and we'll have to be very clear on the distinction of what tool we can use where. Sine, cos and tan are only for right angle triangles, and that distinction will be much more important at Leaving Cert higher level. Now, if I have an angle theta, which again is just a letter we use for angles at higher level, Leaving Cert, the sine of our angle is defined as the opposite, the ratio of the opposite over the hypotenuse of the triangle. The hypotenuse being the side that is opposite the 90 degrees, the longest side of our triangle. Cos is the adjacent, so the side that is adjacent to the angle that isn't the hypotenuse, divided by the hypotenuse, and then the tangent or the tan function of our angle is the ratio of the opposite and the adjacent side. For later on, it is important to be comfortable with the fact that this whole block, so if I take my tan function here, that whole block is this ratio. It can be tempting when we do certain types of trigonometry functions to think that we can treat this like a normal bracket. Say if we had 2 tan here, that we would end up with tan of 2 theta in here, which is not true at all. This whole block, everything in the blue bracket, is equal to this ratio here. So this acts as a single number. We are inputting something into a function and getting the output of a ratio. And it's important that we have this, that we are very clear on this idea that these are functions and theta is an input, so that we're not getting confused with being able to do anything or multiply in to this bracket here. Now, the other note on the way that things are written is that sine squared theta is something that you will see on a fairly regular basis. And what it means is that the sine function is squared. So sine squared with a little 2 sitting just over the n and before the bracket means the whole function squared. And rewriting it in this form can often be no harm for keeping track of things. In terms of remembering our relationships, they are in principle on page 16 in our log tables, but because these tools are used so often, it's better to have them at your disposal immediately. So to that end, there are some rhymes to help you remember these things. So in terms of sine, cos and tan, you could go, oh hell, another hour of algebra, if you like, or Sakatoa is a very common way of remembering. So sine, opposite, hypotenuse, cos, adjacent, hypotenuse, tan, opposite, adjacent is another good way of remembering our trigonometric ratios. And this is all just mostly a recap of junior sci. Now, let's put this into practice and see what a question might look like. If we're told sine of an angle A is equal to 5 all over 13, how would I find tan of the angle A? Well, I could just find out what A is and then take the tan of it, but there's a much better way, a much more problem-solving type way that we do need to know for certain types of questions. If I know that sine of an angle is equal to 5 over 13, if I'm approaching this question, what do I know? What do I need to know? Well, I know that 5 over 13 must be the opposite over the hypotenuse of a right angle triangle. And tan of that angle must be the same opposite over the adjacent to the angle A. So I can draw a right angle triangle with an angle A and a right angle here, because I can only use sine, cos, and tan with right angles. And I know that the opposite is 5 and the hypotenuse is 13. Well, I need the adjacent. I meant to write as a small letter A. I need the adjacent in order to find tan, the thing that I have been asked about. So I want to find the adjacent. How am I going to do it? Well, I have two sides of a right angle triangle, and I need the third. So the tool I'm going to use is h squared is equal to o squared plus a squared. Pythagoras. Very, very common tool. Pythagoras comes up in several different parts of the course. And trigonometry is obviously a pretty important example of that. So my hypotenuse is 13. Everything I sub in goes in brackets. Always. The opposite is 5 squared plus the adjacent I'm looking for. So I end up with 169 is equal to 25 plus a squared. Be careful that you're always subbing in the hypotenuse where you need to in that formula. Minus 25 from both sides, and we get 144 is equal to a squared. I take the square root of both sides to get rid of my squared, and I recognize I must take a plus or minus. So I end up with plus or minus 12 is equal to a. But because a is a length, I can just say that a is equal to 12. I don't need to deal with the plus or minus case in here because a is physically a length of the side of a triangle. So it is just going to be plus 12. We don't deal with negative lengths usually. So now, what do I need? I have tan of A is what I'm looking for, and I need the opposite over the adjacent. And I now have that. Tan of A is going to be the opposite, over the adjacent is going to be 5 all over 12. And that is how I find my tan of my angle. So it's important. This model triangle business where we're able to get the third side and thereby get the other trig ratio is extremely important and will come up multiple times. It is a totally necessary and fairly core skill to trigonometry at Leaving Cert, particularly in problem solving questions that come up in exams. Now, again, how we approached that question was we were given the sine of A is equal to 5 over 13. So what does that tell me? It means in a right angle triangle, the opposite and the hypotenuse are going to be in the ratio of 5 and 13. If I know then I want to know the tan of the same angle, which must be the same opposite over the adjacent. I recognize when I draw my picture that I'm missing my adjacent, and I can use Pythagoras to find that missing adjacent side and thereby find what I was looking for. That's my general approach. Now, the next piece is just some calculator work for the most part. Sine of 35 is just double checking that we're okay with using our calculators. So double check that you get the same answer as I do. When we put sine of 35 degrees into our calculator, what do we get out? We get 0.5736. Now that will only happen if you have your calculator set to degrees. So during our chapter, we're going to need to get good at being able to change our calculator from working in degrees to working in radians. If we don't get this, almost certainly you have your calculator set in radians, and that's why we're getting a different result. Now, the other type of thing that can come up in small parts in our course is degrees, minutes, and seconds. So this would be read as 27 degrees, 32 minutes. The dash is for minutes. Now, there are 60 minutes in an hour. So this means 27 degrees plus 32 out of 60 degrees. So this is basically the same thing as time that you would be already familiar with. So if this was 27 hours, 32 minutes, what would it be in hours? You just divide your minutes by 60 to get your fraction of an hour. So in practice, in terms of putting this in the calculator, what you would do is write in cos, and that will bring up a bracket. You type in 27 and then the degrees button, which looks like an O with some dashes next to it, and then 32, and then the same button again, and close your bracket, and you should get 0.8867 on your calculator. You generally don't do any calculations really with degrees and minutes. You're just required to know that they're a thing that exists. The reason why we use them is the same reason why we have 360 degrees. It made mental arithmetic easier before calculators were a common tool available to people, because fractions of 60 or factors of 60, sorry, there are a lot of factors of 60. So this would have been very close to a third of a degree. Sorry, half of a degree. My apologies. So that's why we have our degrees in minutes. It's a historical holdover, but it is technically on the course, so you need to know how to use it on your calculator. Now, if we're told cos of an angle, in this case I've used alpha, which is another Greek letter that we use for angles. Cos of alpha is equal to this ratio here. Remember, this is again a ratio of sides of a right angle triangle. The adjacent over the hypotenuse ends up being this decimal. If I want to find out what that angle originally was, I'm going to use an inverse function. Now, you've been doing this for years, but in higher level leaving cert, the significance of this will be much more important, so I'm just going to talk more deliberately about it. What we are doing here is taking a function called inverse cosine that undoes the cosine function. So we're taking a function of cosine that gets rid of cosine and leaves us with alpha on the left-hand side. And then this is something we put into our calculator. It's second function cosine, and then this business, and we've put that into our calculator, and you will get approximately 51 degrees. Now, so second function and cosine will give you your angle. It's important to note that this is a way of defining an angle. So inverse cosine of your ratio is defined as the angle alpha, and that it's important to keep in the back of your mind. The final thing to point out is on page 13 in your log tables, there are some special angles, 30, 60, and 45, as well as 90 and 180, that are going to be important for certain ratios that you're going to work with in certain types of problems. If you see the angles 30, 60, or 45 in a sine, cosine, or tan, immediately open up page 13 and see if you can use any of the ratios that are given to you, because there will be exam questions that relate to you being able to spot that you have these special angles, and say that sine of 30 is going to work out to being a half. And so on for the other ones. Those ratios are all on page 13 of your log tables, and you can also just use them on, you can also just find them on your calculator.